So welcome back in this complex analysis class. So this session, we are going to explain how to do what we call change of variables to carry out complex integration. So change of variables. So let Z be given by G of alpha be a continuous function of a complex variable alpha given by U plus I V. Suppose that the curve C in the Z plane corresponds to curve C prime in the alpha plane under the derivative of this function G derivative of the function G so G prime of alpha is continuous on this curve C prime then the integral along C of f of Z dz is given by the integral along C of f of G of alpha and then multiplied by G prime of alpha and then the alpha. This is how we describe change of variables. So specifically, if C is a circle, if the path of integration is array starting at point Z equals to Z naught, or a circle centered at Z naught, we introduce the change of variables. Z minus Z naught equals to rho e raised power I theta as our change of variable expression. So let's do an example. So example, evaluate the integral z squared plus z times conjugate of z dz, where c is the arc of the circle centered at the origin whose radius is 1, and the angle or the argument of this complex number is between 0 and pi. So this is a problem. Solution. Actually, we can try to draw the sketch of this path. So this means a circle of radius 1 unit. So this is how we are moving. So this you have 0, and this one will have the pi. So y x. So we are interested in calculating the integral from the limit 0 to pi. So this is a part of interest, the arc being cited in the problem. So we know that. So we put, so remember when we write that the circle is given by this, z naught is taken to be 0. So when we have z minus z naught equals to rho e raised power I theta, then this is 0. So the same thing as saying let z to be rho e raised power I theta. I remember rho is the radius. So radius of this case is 1. So it tells us that our change of variable will be z equals to e raised power I theta. And then, so which means that dz, so when you integrate, we differentiate this power, you get I e raised power I theta, and then d theta. I remember we had the integral along c of z squared plus z by z, and then dz. So this will give us, so where this dz will be replacing by this, now we'll have the integral. So our we write it as a contour integral. C of z squared plus z times conjugate of z dz will be now the limits 0 to pi, and then so z squared. So because this is the value of z, so z squared would be simply given by e raised power I theta squared, which will give us e raised power 2 I theta. So we'll have e raised power 2 I theta plus, now remember, conjugate of z will give, so z is given by e raised power I theta. So which means that conjugate of z is e raised power minus I theta. So when you say z times conjugate of z is the same as e raised power I theta times e raised power minus I theta. And from laws of indices, we'll have I theta minus I theta. So e raised power 0, so which is just 1. So therefore, this part will be 1. And dz itself is I e raised power I theta d theta. So we have successfully reduced all our integral from having the variable z to the variable theta. So the next would be now just this I is a constant, doesn't depend on theta, so we can pull it out. So we have I 0 to pi, and then I can multiply this one e raised power. Now I have 3 I theta plus e raised power I theta d theta. From the properties of integrals we stated earlier, so this is the integral of sum of two functions, so then the same as adding the respective integrals. So this is what we have. And when you integrate this one, so it's the same thing as having I times e raised power 3 I theta. So integrating this part will have divided by 3i 0 to pi plus this other one will be I e raised power I theta divided by I, and then from 0 to pi. So this I and I cancels, this I and I cancels, so that we have a third into e raised power. So where there's pi, where there's theta, we put pi, so 3 pi I minus, we put 0 here, we'll have just 1 plus e raised power pi I, and then just minus 1. So this will give us, so remember this is the same as a third e raised power 3 pi I minus a third plus e raised power pi I minus 1. So then now minus a third minus 1, this is the same as we're saying a third, and then the same as cos of 3 pi plus I sine 3 pi minus a third plus, this is the same as cos of pi plus I sine pi minus 1. Remember what I'm using is that e raised power theta, this Euler identity. is cos theta plus I sine theta. So this is what I'm using to rewrite these parts. So let's define these values. So cos of 3 pi is -1. So I'll have a third into -1. And then sine of 3 pi is 0. So this will just be plus 0. 0 times I is 0. Minus a third plus cos of pi is -1 plus sine of pi is 0. So 0 times I is 0. And then minus 1. So this will give me negative a third. So this will be 0 minus a third, and then minus 1 minus 1. So I'll have minus 2/3 minus 2. So it will give me minus 8/3 as the solution to my problem. So that is how we use change of variables to evaluate complex integrals. So thank you.